Assalamualaikum. So today I would like to continue our lesson on subtopic 7.2, factors that affecting the rate of reaction. Okay. Alright, so to be exact, in subtopic 7.2, there are 4 factors that affecting the rate of reaction, which are number 1, size of reactant or the total surface area of solid reactant. Number 2, concentration of a solution. Number 3, temperature of the mixture. And also number 4, the presence of catalyst. But today I would like to focus on factors size of reactant only. Okay, for factors number 1, which is the size of reactant, how does the size of reactant affect the rate of reaction? Okay, for information, total surface area factors only affect the rate of reaction that involve a solid reactant sahaja. Okay, when the total surface area of the reactant increases, the rate of reaction will also increases. Vice versa lah, sekiranya kita ada total surface area of a reactant decreases, so the rate of reaction will also decreases. Okay, the total surface area increases if the particle size of the reactant becomes smaller. Jadi dia mesti relate untuk size ni, dia mesti relate with the total surface area. And then it is vice versa. If you have a smaller size of solid particles, maka total surface area that exposed to the collision will be bigger. While if you have a bigger size of solid of a reactant particles, jadi dia punya total surface area dia becomes smaller. Okay, so this one, when comparing between two substance, yang kita nak comparekan in terms of the total surface area and size dia, make sure the mass of the substance is the same. Contohnya, if you have fine sand, nak compare with a stone, make sure the mass of the fine sand 100 gram sama dengan mass of the stone also used 100 gram. Barulah kita boleh compare. So which substance, is it fine sand or stone yang lagi have a smaller size? Of course lah yang fine sand ni yang smaller size kan. Okay, compared dengan stone is bigger size lagi. Jadi kan dia vice versa, maka kalau lah fine sand ini adalah smaller size, so the total surface area of fine sand will become greater or bigger. Stone, sebab dia punya size adalah bigger, maka dia punya total surface area dia adalah smaller. Okay, tapi ingat mass mesti sama, constant kan. Okay, next kita nak tengok between iron wool and iron nail, which material will burns faster? Okay, let's look at this video first.
Which material burns faster, the iron wool or the iron nail? Why does the iron wool burn faster than the iron nail?
Alright, as you can see in the video shown, iron wool burns faster than the iron nail. Dia terbakar dulu daripada iron nail. Of course, kita nak relate with the total surface area. Kalau tengok, total surface area of this iron wool ni, sebab dia bergulung macam tu kan, jadi dia punya total surface area exposed to heat ini lagi besar. Atas pun boleh absorb heat, bawah pun, tengah-tengah pun boleh absorb heat, bawah pun lagilah boleh absorb heat. Jadi dia punya total surface area for this iron wool is bigger than this iron nail. Compared to iron nail, yang exposed to heat hanyalah tepi-tepi batang dia, and then on the head dia dekat depan sini. Jadi dia susah sikit lah nak terbakar because the total surface area is smaller. Alright, so next kita akan tengok experiment 7.1 to investigate the effect of size of reactant on the rate of reaction. Kita akan tengok one by one macam mana eksperimen ni is being done. Okay, first of all, it's a problem statement. How can size of reactant affect the rate of reaction? Okay, and for the hypothesis, kita akan ambil based on variables and also the responding variables. So our MV here is the size of marble chips. The smaller the size of marble chips, our RV is the rate of reaction lah. The higher the rate of reaction. Okay, so MV dah, RV also dah. So our fixed variables is the one that can affect the experiment, tapi kita tak kacau dia, kita kekalkan dia sebagai constant. Jadi apa yang boleh mempengaruhi eksperimen ni is the mass of the marble chips, temperature of the reactant punya mixture, okay, volume and concentration of the hydrochloric acids pun boleh mempengaruhi juga, tapi kita kekalkan sebagai constant variables. Okay, apparatus and materials here. Next is the procedure. So tengok video ni untuk tengok dia punya procedure.
Burette with water and invert it over a basin containing water. Clamp the burette to the retort stand. Record the initial level of water in the burette. Measure and place 1 gram of marble powder into the conical flask. Measure and add 50 cubic centimeter of hydrochloric acid into the conical flask. Quickly insert the rubber stopper into the mouth of the conical flask and start the stopwatch simultaneously. Record the amount of gas released by the reaction every 30 seconds. Repeat the experiment. Replace marble powder with 1.0 gram of marble chips and then 1.0 gram of small marble blocks.
Okay, so that's the last step. The ending procedure dia with repeat the experiment. So kita in this experiment we used one is marble powder, and then one is marble chips. Okay, size dia might be bigger than the marble powder, and the other one repeat lagi with marble blocks, lagi bigger size than the marble chips. If you notice just now during the procedure, it is using the same mass of the marble, which is 1.0 gram. Okay, so mesti kekalkanlah mass yang sama. Okay, next. Okay, dah dapat daripada eksperimen tu dia punya data and observation. Datanya kita akan ambil, kita akan measure the volume of the gas produced. So volume of gas produced ni macam mana nak calculate dia? From the reading of the burette. Kita akan ambil dulu initial reading burette tadi during the experiment, and then kita akan ambil pula dia punya final reading of burette from the experiment, dan kita minuskan the final reading minus with the initial reading. So itu adalah the reading of the burette, itu adalah represent the volume of gas that is produced. Jadi dapat je volume of gas, carbon dioxide gas produced, kita plotkan graph with the time taken. So from this graph, as you can see, when the time increases, the volume of the carbon dioxide gas also increases. Jadi saya nak macam ni lah, bila kita dapat data, kita kena plotkan graph. Of course, it is not a straight line graph. Tidak, dia adalah proportional tapi tidak straight line graph. Dia adalah curved punya graph. So make sure maximum point are touched. So, katalah yang ni contoh daripada 10 points, at least 6 of the points are touched. Okay, yang lagi 4 dia balance 2 sebelah atas dan 2 ni sebelah bawah. Kalau boleh mesti menyentuh, maksimum dia menyentuh lah semua titik. Okay, so ini adalah graph when we use marble chips. Marble chips ni yang medium size tadi, compared to the marble powder and also marble blocks. Okay, ini graph shown when use marble powder. While untuk graph 3, this one shows the result for the marble blocks. Okay, so as we can see in the graph shown here, the rate of reaction for small marble blocks is the lowest. followed by the marble chips and the marble powder. Macam mana kita nak tahu? When we mergekan all these three graph into one graph paper, we can see that the starting point is 0, but then yang paling steeper graph adalah yang ini. So this one represent the marble powder. Dia paling steep curve dia. Okay. Yang medium steep adalah yang guna marble chips. Then the less steep graph adalah yang guna marble blocks. Dia just landai sahaja. Okay, jadi macam mana kita nak kira dia punya rate of reaction ni? Contoh bila kita plotkan one point. Example, kita akan plotkan one point here. So kita akan buat gradient lah. Pengiraan gradient will shows you the value for the rate of reaction. The higher, the bigger the number, the value of the gradient, the higher the rate of reaction. Kalau kita tengok pun, bila kita buat garisan tangent, kat sini, katalah point ini, kat sini dia lagi mendata. Lepas tu kalau kena dekat point sini, dia punya tangent tu agak menegak sikit. Kalau dekat point yang marble powder ni, lagilah tangent dia lagi menegak, lagi steeper. So kalau kita kira gradient, yang ni lagi besar nilai dia, followed by this one, and this one paling rendah nilai gradient dia. Okay, so gradient for the reaction of the marble powder is the lowest, followed by the reaction for marble chips and marble block respectively. Okay, kalau tengok kat sini pun at T1, untuk marble powder dia dah siap dah reaction dia. Dia dah stop produce a certain amount of the carbon dioxide gas. While for marble chips, it will stop reaction at T2. And then last kali with the marble blocks, dia akan stop reaction to produce a certain amount of the carbon dioxide at T3. Paling lambat lah reaction dia. Jadi paling lower rate of reaction. Okay, next. Jadi, as a conclusion, is it the hypothesis acceptable? And then kita repeat balik kita punya hypothesis. Just now, the smaller the size of the particles ataupun the bigger the total surface area of particles, the higher the rate of reaction. Jadi, conclusion kita, hypothesis kita can be acceptable. Okay, seterusnya kita akan tengok examples of reaction that are affected by size of reactant. Okay, number 1, by reaction between magnesium and hydrochloric acid. So untuk reaction ni kita akan tengok one is magnesium ribbon with hydrochloric acid. Inilah ribbon dia. Jadi it is a quite big size compared to another one, dia guna magnesium pieces. Pieces ni just like yang di crushkan. Jadi powder tu dalam bentuk ketulan-ketulan, besar sikit lah daripada powder. Okay. Alright. Jadi kita tengok tadi. Tengok balik okay, this is the graph when we plot the volume of the hydrogen gas release from the reaction of magnesium and hydrochloric acid against time. So makin increases lah as the time increases. And then pada satu point, dia dah complete reaction, dia akan constant and constant. Okay. Untuk next yang guna magnesium pieces. Alright, so yang guna magnesium pieces ini, it shows a steeper graph compared to the one that use magnesium ribbon. Yang ni dia akan stop reaction at this time. And then for magnesium ribbon, dia akan stop reaction at this time. Okay, nampak beza dia. So this one lagi faster reaction with higher rate of reaction. Yang ni dia lagi slower reaction with a lower rate of reaction. Okay, ni explanation dia. At 100 second, kita ambil masa 100 seconds here. Okay, at 100 seconds, the reaction between magnesium pieces yang red line ini, and hydrochloric acid will produce volume of the hydrogen gas is 20 cm3 of hydrogen gas. While for the reaction between magnesium ribbon yang blue lines ini, pada 100 seconds ini, dia just produce 16 cm3 of hydrogen gas. Okay, so kita kata 20 cm3 ni pada masa 100 second. Jadi dia lagi faster reaction lah compared to the reaction between magnesium ribbon and also hydrochloric acid. Jadi kalau kita tengok graph pun, the graph of the reaction for magnesium pieces ini is steeper than the graph for the reaction between magnesium ribbon and hydrochloric acid. Okay, jadi bila steeper ataupun lesser graph tadi will resulting in higher rate of reaction. The one that have steeper graph has a higher rate of reaction. The one that has a less steep graph has a lower rate of reaction. Okay, reaction number 2, reaction between zinc and sulfuric acid. Again, what we manipulate here is the size of the particle, size of the reactant. Okay, since sulfuric acid dalam bentuk solution, maka dia tak boleh mempengaruhi lah size. Jadi yang dipengaruhi adalah size of the solid particle sahaja, zinc ni. Satu zinc granules dan satu lagi dalam bentuk zinc powder. Kita tengok Alright, dah siap dah reaction dia. Okay, when zinc granules react with sulfuric acid, it will produce hydrogen gas. Okay, jadi hydrogen gas ni kita ambil melalui water displacement method, which is water inside the burette will be displaced. Jadi lama-lama dia akan makin berkurang. Maka kita akan ambil initial and the final reading of the burette untuk calculate dia punya volume of gas produced. Jadi volume of gas ni daripada yang kosong, sebabnya penuh dengan air, jadi kosonglah volume of gas. Dan dia akan increases sampailah at one point dia akan stops increases, sebabnya dia dah complete reaction. So ini graph untuk zinc granules. Okay, zinc granules. Next one, zinc powder.
Which experiment has the fastest rate of reaction?
Okay, ditanya soalan. So which experiment, how do we know which experiment has a higher rate of reaction or faster reaction? By analyzing the graph, which one has a steeper curve, yang red line ni ke ataupun yang black line ini. Okay, of course lah yang red line ini, because this one use zinc powder. So tengok graph dia ke depan, so maksudnya dia adalah steeper curve lagi. Kalau yang makin ke belakang macam ni, dia macam landai sikit, so dia less steep. Okay, so this one, kalau kita ambil satu point pun, dia akan mengexplainkan yang contoh at this time, yang ni akan produce sebanyak ini volume, yang ni akan produce kurang sikit volume dia. So yang ni lagi faster reaction ataupun higher rate of reaction by using the zinc powder. Okay, ni explanation dia. Which experiment has the higher rate of reaction? Of course, kita akan pilih yang zinc powder. Okay, the rate of reaction between zinc powder and sulfuric acid is higher than the rate of reaction between zinc granules and sulfuric acid. Okay, so what is the relationship between the size of reactant and the rate of reaction? Okay, look here, the keyword is here, the greater total surface area. Must be vice versa with the size. So if greater surface area, the size must be smaller. Okay, so the smaller the size of reactant, the greater the total surface area exposed for the reaction, hence the rate of reaction will be higher. Okay, so why do you think the smaller size of reactant will produce a faster reaction? Okay, so this is the explanation. Let's listen.
Let's take an example of a chalk cube measuring 2 centimeters by 2 centimeters by 2 centimeters. A cube has 6 sides in all. Calculate the total surface area of the chalk cube. Now, let's say we cut out the same chalk cube into smaller 1 centimeter by 1 centimeter by 1 centimeter cube. This results in 8 smaller cubes. Each cube has 6 sides. Now, calculate the total surface area of the chalk cubes. Can you calculate the number of the exposed sides on one chalk cube? Yes, the number of exposed sides in one chalk cube is 6. Can you calculate the number of exposed sides for a chalk cube that has been cut into 8 smaller cubes? Sides for a chalk cube that has been cut into 8 smaller cubes is 48. The number of exposed sides for each type of chalk shows the amount of space available for collisions with molecules.
Alright, so faham tak? Ini explanation based on the size or surface area of the reactant. Ambil contoh macam ni je lah. Kalau kita ambil one bigger size of this cube, dia ada 6 kan surface area exposed to collision. 1 from top, bottom, 2 from sides, 3 and 4 from at the front, 5 and 6 at the back. So exposed surface area ni adalah 6. Tapi if this one bigger cubes is cut into 8 smaller cubes, satu ni dia ada 6 surface area. Jadi katalah 8 pieces of this cube, 6 times with 8 dapatlah 48 exposed area. Jadi yang ni 6 sahaja. Yang kecil-kecil ni ada 48 exposed area. 6 dengan 48, of course lah 48 ni lagi bigger total surface area that exposed to the collision. Jadi that's why lah reaction of particles becomes more faster bila bigger total surface area exposed.
Let's take an
Okay, inilah total surface area bigger when compared to a larger chalk cube. Dengan syarat mesti at the same mass. So yang ni kalau 2 cm 2 cm 2 cm 2 cm sini, yang ni pun sama 1 cm and 1 cm here. So it will resulting in the same mass. Tapi as the size of the chalk cube is smaller, dia punya total surface area will become larger. So the smaller the size of the reactant, the bigger the total surface area. Maka rate of reaction will become higher. Alright, so kita dah sampai ke ending dia. Kita summarizekan kita punya lesson. In this lesson, we have learned that the smaller the size of the reactant, the faster is the reaction. The process is quite faster. And then, for smaller size reactant, the total surface area is bigger. Okay, apa yang mempengaruhi size tu adalah total surface area. Jadi, resulting in the rate of reaction will be higher untuk smaller size reactant because total surface area ni yang bigger. Alright, that's all for today. Thank you. Goodbye. Have a nice day.